Okay, this is from my book, Prevent and Reverse Heart Disease by me. I'm sorry, Prevent and Reverse Diabetes by me, Pete Rogers. We're on like page 64 of the book. We just finished up last time. This is like, I think, part 7 or something, this lecture here. We're talking now about electron transport. This is the intermitochondrial membrane. These are the carriers. So this is complex 1. It receives electrons from NADH. That's important to know, NADH. This is complex 2. It receives electrons from FADH2. Okay, they're passed down through these carriers. The electrons, that's shown in green. The protons are pumped into the intramembranous space. That's how electron transport works. Basically, it has split the atom. It's a nuclear power plant, and then it harvests the gradient of protons by letting them come back in to make ADP. Okay, by the way, there's something interesting and unique about complex 2. Complex 2 is the enzyme succinate dehydrogenase, and if this isn't running or it's inhibited, then you start to accumulate its substrate, which is succinate, and that succinate can travel out of the mitochondria, go into the cytoplasm, and it will activate hydroxy-inducible factor and sort of initiate that hypoxia pathway. So if you were to have a mutation in this enzyme or an inhibitor of that, you can get an effect that's called pseudohypoxia. We'll come back to all that stuff later. There's interesting things about a mitochondria, but I'm just telling you, the mitochondria is fascinating. It should really be something studied much more. Okay, so I want to show you here like what happens when you have mitochondrial inhibition. So let's say you inhibit by saturated fat right around this region of coenzyme Q and complex 3. Then the electrons can't be passed along to the carrier, so the electrons start to drop into the matrix. When they drop into the mitochondrial matrix, they will combine with oxygen, and you'll produce this free radical here, superoxide, with an unpaired electron in the outer orbital. Now, the superoxide most of the time is quickly neutralized by superoxide dismutase, SOD, and into hydrogen peroxide, and that can be then further converted into water, H2O, by catalase or glutathione peroxidase. Okay, that's what normally happens. But if you have an overwhelming amount of these superoxides, they can undergo harmful reactions, like they can combine with nitric oxide to make peroxynitrite. The hydrogen peroxide can undergo a Fenton reaction, interacting with the iron, free iron. If you have abnormal excessive free iron, you can produce hydroxyl radicals, damage the membranes. So you don't want excessive amounts of these superoxides. Just so you know, that's one of the big problems of insulin resistance. Insulin resistance is a bad thing. That's another reason why it's bad to eat a lot of fat. Okay, all this stuff is the verbal explanation of what I just told you. Okay, now here is the fat stages of diabetes. Just to kind of review them, I know we briefly had alluded to these before. Accumulation of fat in the skeletal muscle, so you get high blood glucose after eating because that causes insulin resistance in the skeletal muscle, postprandial hyperglycemia. Accumulation of fat in the liver, fatty liver, that's prediabetes or diabetes of the liver. The liver can no longer accurately sense glucose, blood glucose level, so it tends to keep on pushing out too much glucose into the blood, and now you get fasting hyperglycemia. Then you accumulate fat in the pancreas, and it destroys the beta cells of the pancreas, and eventually you can't make insulin anymore. And these are just secondary complications of diabetes. Okay, here is just to show where the excessive fat, especially saturated fat, causes inhibition of the intermitochondrial membrane, right in the region of coenzyme Q and of complex 3. Okay, and that's also going to cause a backup of succinate. That's not good. You don't want that. Okay, and it's the phrase that's often used is overnutrition. Here's how insulin normally works. Insulin will bind to the receptor on the skeletal muscle cell. Okay, this is in the extracellular space. It comes from the blood. It then exerts an effect upon the skeletal muscle cell to cause the glucose type 4 transporters to travel from their cytoplasm vesicle on up to the plasma membrane, merge with the plasma membrane, and then function as a channel to allow glucose to come into the cell. It quickly gets phosphorylated as the first step in glycolysis by glucokinase or hexokinase, you might call it, the enzyme. And that traps it in the cell because now it's got a big charge on it. It can't exit out. And that's how a skeletal muscle takes up glucose after eating. And that's where the majority of postprandial glucose should go. And the skeletal muscle will store it as insulin. Store it as glycogen. Okay, when you have the saturated fat blocking the intermitochondrial membrane, then it sends a message to the cytoplasm to not allow the glucose type 4 transporters to go up to the plasma membrane. And they call this overnutrition. But that will block the glucose type 4 transporters from going up to the plasma membrane. So now the blood glucose can't get into the skeletal muscle, so it accumulates in the blood, and that gives you hyperglycemia. Prandial means eating, so postprandial hyperglycemia means high blood glucose after eating. Okay, and then that high blood glucose goes to other locations and causes problems because there's other cells that just take up blood glucose in a constitutive fashion, meaning that they take it up in the proportion to whatever amounts in the blood. So you have chronically elevated blood glucose. That means you're going to get chronic excessive amounts of glucose going into cells, and there's some cells that are very fragile and damaged by that, including the endothelium, so you get a microvasculopathy, including the eye, so you get diabetic retinopathy, including peripheral nerves, so you get peripheral neuropathy, okay? Including the kidneys, so you get diabetic nephropathy, and you also get microvasculopathy in the brain. We notice it most in the foot because that's where you get all the amputations, but it's simultaneously causing a lot of brain damage as well. Diabetics are notoriously stupid, type 2 diabetics. They can prevent that, but most of them don't, so they're usually pretty stupid. The longer they've had it, the worse their cognitive function is. Okay, so here is starch alone. You have a pretty good blood glucose curve, a small expected normal spike in blood glucose level after eating, and then it stays in the normal range a prolonged amount of time. If you eat fat first, that will cause insulin resistance because it gets in the skeletal muscle first, and then you'll have postprandial hyperglycemia, and you'll have prolonged elevation of blood glucose. Okay, so this is what is called carbohydrate tolerance, and you have less carbohydrate tolerance if you eat fat first because it causes insulin resistance. And that's why it's okay for diabetics. It's good for them to eat fruits and starch. They just have to make sure they don't eat the fat. If they eat the fat first, then this is going to spike their blood glucose a lot. But if they don't eat the fat first, then it doesn't. And so that's why the important thing to do is avoid the fat. As Dr. McDougall used to say, these diabetics should not be carb counting. They should be fat counting. Minimizing their dietary fat, they'll be a lot better off. And Dr. McDougall would emphasize the best thing for them is to eat a low-fat, starch-based diet. I can tell you the Mastering Diabetes guys, it used to be Bobby Bitterow and Cyrus Kumbada, but now it's mostly Bobby Bitterow. Cyrus went with some other place. The fat just gets into the skeletal muscle cell. You can't stop it, like by a mass action, or you can call it a flip-flop maneuver. The fatty acid intercalates itself into the outer leaflet of the plasma membrane and the skeletal muscle cell, then it flips into the inner leaflet, then it goes into the cytoplasm, and it gets to the mitochondria before the glucose can, and then it causes insulin resistance, and it backs up the whole process. So the smart thing is just minimize your intake of dietary fat. It's nice to know what to do, and the worst is sat fat, but it's good to minimize your intake of all dietary fat, because all of it's obesogenic, all of it ends up increasing your insulin work. I'm not going to go through all the text. Here's the great paper. You can get this. You can even read the paper for free online. It's called The Pathobiology of Diabetic Complications, a Unifying Mechanism by Michael Brownlee. It's an awesome paper. It's one of the greatest medical papers I've ever read in my life. It's beautiful. The Sistine Chapel of Diabetes paper. So here it is, a little more of a so-called abstract. It's not a regular abstract. It's more like an introduction to the lecture. It's the Banting Lecture of 2004 because Michael Brownlee won that award as the best diabetes researcher in the world, okay? Trust me, if you're interested in diabetes, understanding the complications, it's a magnificent paper. If you're a patient and you just want to get better, avoid the things that cause insulin resistance. Eat a low-fat, low-sodium vegan diet with no oil, organic only, no alcohol, no caffeine. Walk a lot, you'll be amazed at the progress you make. I go through the other causes earlier in this book. Okay, we talked about producing more superoxides. Okay, another thing that happens is you'll start to damage the DNA a bit, and you'll get a DNA repair enzyme activated. It's called PARP, okay? And then PARP has many effects, and one of the effects it has is that it inhibits glyceraldehyde 3-phosphate dehydrogenase, a glycolysis enzyme, and that ends up being a very big deal. So once it blocks this glycolysis enzyme, glyceraldehyde 3-phosphate dehydrogenase, then you start running all these, the preliminary substrates of glycolysis back up. They accumulate because it's like a traffic jam, and this is all the backed up traffic. And then they start running side pathways. They run a PKC pathway, which leads to insulin resistance, blockage of the glucose type 4 transporters. Glyceraldehyde also, part of it gets converted into methylglyoxal, MGO, and that leads to the production of advanced glycation end products. And so this basically creates a whole storm of problems for the cell. This is the one I joked about being like, unleash the dogs of war, because you produce tremendous damage to yourself by allowing things to get this far. So I'll stop this session on diabetes at this time. We'll come back at this page and the beginning of a discussion of advanced glycation end products. But the teaching point of all this stuff is if you got diabetes and you want to get better, avoid the things that cause it. Avoid excessive dietary fat, excessive dietary sodium, estrogenic chemicals, mitochondrial inhibitors, and all the other things talked about in the what causes insulin resistance. So hope that's helpful.